Okay, this is on series circuits. Question 1. Which direction does a charge flow out of the battery? Okay, so it goes from positive to negative, so that way. Okay, what is the current in the resistor? So this is resistor R. There's only one, so I'm not going to number them. And I want to know the I that goes out of that in amps, right? So I know the voltage V. Well, V equals IR. So I get, if I want to solve for I get V over R. So I get I is 12 volts divided by 10 ohms, which is 1.2 amps. And I want to know the voltage across that resistor. So I can do V equals IR 1.2 times 10 and get 12 volts. Now that's true because there's only one resistor, but let's see what happens if there's more than one resistor. Okay. Now there's a couple, actually two key points you need to know. That's one, and this is for any components in series that are resistors. Alright. The equivalent or total resistors is R1 plus R2 plus R3 plus however many resistors you have. And the current, so that was for the resistors in series. The current in series is the same. So the equivalent current is the same current that's in each resistor. Alright, so this is plus, this is minus. The current is going to go around this way from plus to minus. So I'm going to number this resistor R1 and I'm going to call this resistor 2. Okay? Now I want to know the total resistance of the circuit. I want to know the current, voltage, and power in each resistor. So what might be nice to do is make a table. So I'm going to write current position. Let me start that over so you can read it. Current position. So I'm going to have a 1 and a 2 and a total. Okay, then I'm going to have voltage, which are measured in volts, of course. I'm going to have my current, measured in amps. I'm going to have my resistance, measured in ohms. I'm going to have my power, measured in watts. Okay, and I'm sorry it's running the picture a little bit. So my total voltage is 9 volts. What's my total resistance? Well, my resistance just adds up, so I get 15 ohms. Because 1 was 5 ohms, and 2 was 10, so that makes 15 total. Okay? Now, the total current, so if I want I know V equals IR, so I equals V over R. So the I equivalent is going to be V equivalent over R equivalent. Okay? I equivalent equals V equivalent over R equivalent. So I'm going to get 9 volts divided by 15 ohms is what? 0.6 amps. So the current total is 0.6. That means the current in each resistor is going to be 0.6. If I wanted to label it on the picture, I could say I1 is 0.6 amps and I2 is 0.6 amps. Okay, so what would the voltage be then? Well, 0.6 times 5 is 3 volts and 0.6 times 10 is 6 volts. So, and then you should notice that the voltage is up to 9 volts, which is what I wanted. Now the total power would be IV. Remember, power equals IV. So 0.6 times 15 or 0.6 times 9, I'm sorry, is 5.4. And then 6 times 0.6 is 3.6. And 3 times 0.6 is 1.8 watts. So if I add 1.8 3.6, I get 5.4 watts. So my table gives the answer to all the questions. Okay, then we have one more problem, one more example. 3. So this is 10 ohms, this is 20 ohms, and this one here is 30 ohms, and my voltage is 6 volts. So my REQ is going to be 10 plus 20 plus 30 ohms, which is going to be 60 ohms. And that means my current, so V equals IR, I equals V over R. So 6 volts divided by 60 ohms is 0.1 amps. So that means my current is 0.1. Now V equals IR, so 0.1 times 10 is 1 volt, 2 volts, 3 volts, which adds up to 6 volts. And my power is IV, so I get 0.1 watts, 0.2 watts, 0.3 watts, and that should add up to my total, which is 0.6 watts. And that's how you do series circuits.